Okay, so let's get started. The first question says, given the rational equation, determine the following. Okay, so we have a rational equation. So let's first factor this out to figure out if there are any holes. And as you can see, x minus 1 and x minus 1 cancel out, meaning they just divide each other out. So that is our hole. So x minus 1 is equal to 0, gives us our x coordinate of the hole. Now let's write it out as a simplified function. X plus 2 times x minus 3 over x times x plus 5. Okay, so first it asks for our hole. So if we have a hole, it's pretty easy to just like figure that out. And then if we plug it in back to in our simplified equation, we can find out what the exact coordinate of that hole is. So let's plug it in. 1 plus 2, 1 minus 3 over 1 times 1 plus 5. So we get 3 times negative 2 over 6, which is just equal to a negative 1. So our coordinate of our hole is 1 comma negative 1. Okay, so now we have our hole. Now let's figure out our vertical asymptote. Let me just clear my workspace here. Okay, let's figure out our vertical asymptotes. To find our vertical asymptote, what we do is that we set the denominator equal to 0. So x times x plus 5 equals to 0. So what that gives us is that our vertical asymptote lies at x is equal to 0 and x is equal to negative 5. So let's write that out. X is equal to 0, x is equal to negative 5. So there are two vertical asymptotes, which makes this graph even more interesting. Now to find the horizontal asymptote, there are several different ways, but in this particular case, since this is a same, meaning there are the same amount, same degrees on the top and the bottom, so we're just going to take the leading coefficients of both, so both the top and the bottom, and divide them by each other. So since they're both 1, our horizontal asymptote lies on y is equal to 1. Now the x-intercept and the y-intercept. Okay, so some things we know about the x-intercept. So the x-intercept happens when our y value is equal to 0. So if we set our y value equal to 0 and then solve for the x-intercept, that's a very easy way to do it. So let's see, x minus 3 and x times x plus 5. Okay, so when we solve and we have a 0 on the left side right here, and we multiply by the denominator to cancel out the denominator on this side, 0 multiplied by anything is just 0. So this just cancels itself out. And now we are left with the equation we can solve. So our intercepts lie at x is equal to negative 2 and x is equal to 3. Now let's write the coordinate for that right here. So negative 2 comma 0, u 3 comma 0. Now the y-intercept is when we plug in a 0 for the x's instead of the y. So let's do that. So 0 plus 2 times 0 minus 3 over 0 times 0 plus 5. So the bottom actually comes out to be a 0, which means there are none y-intercepts. And you could have probably predicted that by just looking at the vertical asymptote, x is equal to 0. So it doesn't touch x is equal to 0. Okay, now let's get graphing. So first, let me graph our asymptotes. So our asymptotes lie on x is equal to 0. So x is equal to 0 is the y-axis. So right, let me just do a different color and make it a little thicker so that it's easier to view. And then let me do a dotted line. Okay. There we go. That's our first asymptote. And our second asymptote lies on x is equal to -5. So 1, 2, 3, 4, 5. So right here. And there we go. Those are our two asymptotes. Two vertical asymptotes. Now we have to graph our horizontal asymptote, which lies at y is equal to 1, so it is right here. Okay. Now we also know our x-intercept, so we can graph that and make life a lot easier for us. So let's do that. So our x-intercepts lie at -2, 0. So -2, 0, and 3, 0. 1, 2, 3. Right there. So we already know what this side of the graph will look like. It'll probably look something like this, but we can get more points if we want to, and I'm gonna do that right here. So let's see, if I plug in, let's say 1, let me plug in the point 1 into our equation. So we get 3 and then -2 over 1 over 6. So we get, oh, that's our hole. Okay, so our hole lies right here. Our hole lies right here at 1, -1. So right there is our hole. Our hole. Okay, 1, -1, and we have our hole. So now 1 didn't work, so let's just plug in 2, and let's see. So after we plug in 2, we get 4, and then -1 over 2 times 7. So I'm plugging in 2 into this equation right here. So -4, okay, so that's not a good point. So let me just say that, let's see. So you could graph other points, and that's like makes the graph even more accurate, but in this case you don't actually need to, since you already know what it's actually going to look like, and you can figure out more points by just plugging in x values into the equation. So I'm just going to graph this part right here like that. So it's, let me redraw that. So okay. So something like that. So it's approaching our horizontal asymptote. Okay. Now let's figure out whether our graph on the left side is right here or right here. So we can do that by plugging in a point. So let's say we plug in, what's this point? 1, 2, 3, 4, 5, 6. Let's say we plug in -6. Okay, so if we plug in -6 into the equation, we get -4 times -6 minus 3, -9, all over -6 times, what's that? -1. Okay, so 6 over 36 gives us 6. Okay, so our next point is -6 comma 6. So -6 is right here. 1, 2, 3, 4, 5, 6. Right there. So now we know how our other graph is going to look like. So let me do it more clearly. 1, 2, 3, 4, 5, 6. So it's going to be like that. And as I said, you can graph other points. So let me try for one more. If it gives us an accurate point, I'll graph it. So let me plug in a -7. So that gives us -5. -5 times -10 all over -7. So all over 14. So that's like 50 over 14, which is around, let's see, 2, 3, 4, so 4, no, a little less than 4, so 3 point, let me just do it on my calculator. 3 point what? So 50 divided by 14 is 3.57. So it goes up 3.57. 1, 2, 3, 3.57. So somewhere around there. So now we have a more accurate graph. So it goes something. Oh, wow. Okay, so I redrew the graph. Now let's do the middle part. So we have our first point. So it's right there, meaning our graph goes like this. But let's plug in another point just to be sure that it doesn't turn or just go up like that. So let's figure that out. Let's plug in this point right here, which is a -1. So and then when we plug in a -1, we get a -3 times a -4, then over a -1 times 4. So we get -12 over -4, which is a 3. So our next point is -1 and 3. So -1, 1, 2, 3, right there. So you see how the graph crosses the asymptote? And I was saying that let's make sure. So you always have to make sure if your graph is like that. So that's our new graph. And we have graphed it. Okay. Now given the logarithm equation, the equation right here, simplifying using properties of logs and graph. Okay, so first we simplify. So we'll simplify these two right here. So you always have to make sure that when you're using properties of log, you have to have the same base. And since there's no base present here, we just assume that it's a 10. We don't assume it is a 10. So like we know it's a 10. Okay, now when there's subtraction here, we're going to use the quotient rule, which says that you can divide the arguments. So you divide the arguments plus log of 2 plus 7. Now we can use the product rule, which says that you can multiply the arguments if they have the same base. If the logs have the same base. So right here, you get x plus 4 times 2 over 4. So that's just we can simplify that and make it log base x plus 4 over 2 plus 7. Okay, now it says simplified logarithm in form of f of x is equal to a log b of x minus h plus k. Okay, so let's do that. So let's do that. And okay, so we don't have a vertical compression or shift. I mean vertical compression or stretch, so we can leave it like that. And so log times b, which is our horizontal, and we have a horizontal stretch of 1/2, and then you have x plus 4 plus 7. Now f of x is equal. This is our function. Now that we have our function, let's start graphing. So first we're going to figure out our asymptote, and in a log function, we always have, I mean if it's a log, if the function is a log, we always have a vertical asymptote. So usually the vertical asymptote is just the y-axis, or x is equal to 0. But since we have transformations, it's going to be at a -4 because of this plus 4 right here. So 1, 2, 3, 4, and there we have our point. I mean, not our point, but our asymptote. Let me draw a dotted line, and there we go. And there we go. And now I'm going to plot the point which is going to help us graph all the other points. So that point is going to lie at -4 and 7 because of this transformation right here. And from this point, this is basically going to be our new origin, and we can go from this point we're going to graph all our other points. So 7. So up 7, 1, 2, 3, 4, 5, 6, 7. So right. 2, 3, 4, 5, 6, 7. Okay. Now that we have 7, let's get to graphing. So we always have to remember that if we don't have a base, or if a base is not there, a base is 10. So if our base is 10, I always like to write an equation which helps me with logs, because since it's like always switched around, so like I always think about it as 10 to the y is equal to x. So I think as that y is my input and x as my output to make it easier on myself when I'm graphing. So let me draw a table, x and y, and let's think about what points we know are on the original. So not with all these transformations, but just the log function. So if we think about that, we know that it's 1, 0, or the pivot point on the original one is right there. So if we have 1, 0, we also have a horizontal stretch. So if we have a horizontal stretch so it says 1/2 here, but it's actually by a factor of 2. So we multiply every x value by 2. So multiplied by 2. So now from our make up origin, or the origin, or let's just say it's the point from where we graph, so we go to the right 2, and there we go. That's our first point. Now we have our pivot point, which is going to lie at 2, not 2, let's see, -2 and 7, -2, 7. That's our pivot point right there. Now, if I plug in a 1, or if y is 1, x is 10. We multiply by 2, so that's 20. So can we go 20 to the right? Well, our graph wouldn't allow that. So our only choice is to plug in a -1, which will give us a 1 over 10. Now, if we multiply that by a 2, we get a 1 over 5. Oh, sorry. So we get a 1 over 5. So we do down 1 and... Okay, so to the down 1, and so it's less than 1/2, so let's say right there. And now we can't go 3, so let's go -2, which gives us 1 over 100 multiplied by 2, which gives us 1 over 50. So -2, down 2, and to the right, like very little. So like, let's say like right there is our point. And there we go. We have our graph. We have 3 points. There we have it. There we go. And we can erase this point right here. And we can make this point a little larger, this point a little larger, that point a little larger. There we go. Now our domain is not all real numbers, but it starts from our asymptote, which is at -4, and goes all the way to infinity. Our range is all real numbers, so -infinity to positive infinity. Our end behavior is as x reaches infinity. So as x reaches infinity, y, or f of x, reaches infinity as well. But x cannot reach anything below a -4. And while x is reaching -4, or as x reaches -4, y reaches -infinity. And our asymptote is at x is equal to -4. And there we go. We have graphed this function right here. Okay, now the next is determine the inverse equation and graph. So, okay. And I'm going to algebraically solve it because it's asking us to determine the inverse equation and then graph. Otherwise, I would have just graphed the opposite points and called it a day, but we can't do that. It's asking us to solve. So x is equal to log of 1/2 y plus 4 plus 7. So first we start off by subtracting 7, so we get x minus 7. Now, which is equal to the log of 1/2 y plus 4. Now that we have that, there is no way out but to include. We have to change it to the exponential form. So 10 to the x minus 7 is equal to 1/2 times y plus 4. So now we have to get rid of this 1/2, so times 2. So we get 2 times 10 to the x minus 7, which is all equal to y plus 4. And we get minus 4, so we get 2 10 the x minus 7 minus 4. Okay, is equal to y. Our new function f of -1 of x is equal to 2 times 10 to the x minus 7 minus 4. Okay, we can shrink that, and we have our inverse. Okay, let's circle that right here. And now, so we have determined the inverse equation, and now we have to graph. Now to graph, we also have to know what the actual parent function of an exponential form looks like. So it looks like this, and the asymptote is y is equal to 0. Now that's going to change. The asymptote is going to be at -4 because our whole graph is moving down by 4. So at -4, we're gonna 1, 2, 3, 4, draw a dotted line representing our asymptote. There we go. There we go. Asymptote. Done. Okay. Now that we have our asymptote, let me graph the point from where we're going to determine our whole graph, which is going to be 7 comma -4, 1, 2, 3, 4, 5, 6, 7. So there we go. 7 comma -4 is the point from where we're going to determine all our other points. This is not an actual point on the graph. Okay, now that we have that, let's make a table, x and y, and let's think about the points that are actually going to be on the parent function of this exponential, which is going to be 0, comma 1, also known as the pivot point, but that's going to change because of the transformations. And we also know that there's a vertical stretch. Yes, there's a vertical stretch by 2. So we're going to multiply everything by 2. And I mean the y values, not everything. So there we go, which is equal to 2. And now meaning it goes to, so our first point, we actually know what it is. Well, do we? Yeah, we do. Our first point is, so it's going to be right there. That's our first point on our graph. And then for our second point, let me just do my handy dandy equation. 10x is equal to that. If we plug in 1, we get 10. And then we get 1. No. Oh, not 10. We plug in 1 and we get 10. So 10 times 2 is 20. Okay. So 20. I don't think we have space for that, but let's try it anyway. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No, we do not have space for that. Okay, so we plug in 0, let's plug in a -1. So we get 1/10 times 2, meaning we get 2/10, which is 1/5. So -1 and 1/5. So 1/5 is less than 1/2. So it's going to be somewhere around, so that became a line, so somewhere around there. There we go. And our only choice, because we cannot plug in 2 and make it, so we cannot plug in 2 and 1 is still too big. Our only choice is to plug in -2, which gives us 1/100. 1/100 times 2 is 2/100, meaning 1/50. Okay, I don't know. Okay, so let's just try to graph that. 1/50 and to the left 2, 1, 2, and like, let's say right there. So that's our graph. Oh, there we go. Okay, now we have our domain. Our domain this time is, so let me just erase this point. Our domain this time is going to be -infinity to +infinity. And our range is going to be from -4 to infinity. Now, if this is a true inverse, the domain and range should have flipped, and they did. Now the end behavior is going to be as x reaches -infinity, Oh, f of x. Let me go and change that on the top as well. Y might be incorrect. I don't know, but let me go do f of x and f of x. There we go. So f of x or y will essentially be reaching -4. And as x reaches positive infinity, y will be reaching positive infinity. And they have flipped as well. So as x reaches negative infinity, y will be, okay. And our asymptote is gonna be at y is equal to -4. Correct. And our pivot point. Okay, so our pivot point is this point, which is at 7 comma -2. 7 comma -2. And there you go. That is day 3. And thank you.